The violent awakening of a long-dormant volcano earlier this month in South America was a reminder of the natural processes that can change the composition of the atmosphere, both on local and sometimes even global scales. Now, the Chaitin volcano is in southern Chile. That's the pencil-thin country that stretches about 2,500 miles north to south on the west coast of South America. If it were in the northern hemisphere, Chile would run from the latitude of Mexico City all the way to central Canada. The volcano hadn't erupted in more than 9,000 years until May 2nd. A more violent eruption came 4 days later, sending a plume about 18 miles into the sky. Prevailing winds in the mid-latitudes of the southern hemisphere are westerly, just like in the northern hemisphere, so nearly all the ash and smoke headed east, covering the ground in parts of Argentina's Patagonia Plateau. In several inches, even feet of grayish, dusty ash and smoke. This area only gets 5 to 10 inches of rain a year because it sits in the rain shadow of the Andes Mountains, so it'll take a long time to naturally cleanse the land. In addition to the blizzard of soot, the Chaitin volcano produced another spectacular weather-related effect, a lightning show. Such volcanic-produced lightning hasn't been studied much, but at least some of the electrical charge is probably generated by collisions among rock fragments, ash, and ice in the volcanic plume. This is similar to how lightning forms in regular thunderstorms, but there's just different-sized ice particles colliding. In a way, the volcanic cloud is a bit like a dirty thunderstorm. Now, the biggest volcanic eruptions can have global effects. The best recent example is Mount Pinatubo in the Philippines, which was linked to about a degree of global cooling in the lower atmosphere after its 1991 eruption. But this is unlikely with the Chaitin volcano for a couple reasons. Pinatubo spewed a huge amount of sulfur dioxide gas into the stratosphere, 15 to 20 miles up, where it's converted into tiny aerosol particles that reflect a little extra sunlight back to space. And because the stratosphere is a stable layer above most weather, the particles stay in the air long enough to spread globally. The Chaitin volcano's plume was also pretty tall, but it's only emitted a small fraction of the sulfur dioxide that Pinatubo did. In addition, Pinatubo is in the tropics, which makes it easier for its debris to get circulated into both the northern and southern hemispheres. Chaitin is about halfway between the equator and the South Pole, so any effect it might have would likely be limited to just the southern hemisphere. Coincidentally, last weekend was the anniversary of the 1980 eruption of Mount St. Helens in Washington state. As infamous as that was, the amount of debris it sent into the air was many times smaller than what Pinatubo produced. And most of it stayed in the lower atmosphere, so it only had short-term regional effects in the northwestern United States. Paul Knight will be back with the extended forecast next.